Shall we start?
Yeah.
Okay, cool. So I looked over your like mock test and like I was proud of like your work like on everything you did pretty much. Like especially the graphs like very like pleasantly surprised as always. And again because like like it's a lot of information and like you have like like you took all of that information and processed it and kept it very well. So I'm very happy with like the majority of your work. So I mean, like almost all of it. Like there are some blanks you left, and we're gonna talk about those. So for no other reason than like the review packet like repeats some of the mock test, and I was consulting your review packet and your old quizzes as I was creating this. Let's look at your mock test first. Okay, so let me know when you have that handy. Well, you have it in front of you also.
Um,
Okay.
yeah. Okay, I got it.
Okay, so 1A, like beautiful, very well done. I was particularly happy with the fact that you knew to do -3 because it says x plus so it's +3 with the x, and so you knew that it had to be a -3 there. Okay, great. So that's right. And axis of symmetry, again, very happy. You can probably hear it in my voice. D, excellent work. Like I like looked through like all of your arithmetic that you had like simplified correctly, blah blah blah. Now just like quick glance. Anyway, C though, like you left it blank. ¿Por qué?
I thought, like, wouldn't it come out to something weird?
Say that again.
Wouldn't it come out to like not a number, like something that, like not just like like 5 or something? Like, isn't it gonna come out to something like really weird?
It's all good. It's okay. Sorry. So how do we find the x-intercept?
Set y equal to 0.
Yeah, exactly. So good job. Like I mean, again, like given that you like like you did like algebra over like a month and a half. Like I'm really happy with where you're with it. Excellent job. Okay, so if we set y equal to 0, well y is f of x we know. So that means set f of x equal to 0. So what we have is 0 is equal to -2 times x plus 3 squared and then plus 4. So talk to me. Where do I go from here?
Well, I guess you would square x plus 3.
If it's like this, like move the constant over to the left side first. So go ahead.
Oh, okay, yeah. So
It's okay.
then that would just be, yeah, -2 equals x plus 4.
Which constant do we move?
Oh, I moved both of them.
Sorry, say that again.
I moved both of them.
Okay, it's okay. It's okay. One at a time. Go ahead.
So yeah, I guess we could start with the 4. So -4 equals 2 times.
Yep. So -4 equals -2 times x plus 3 squared, and then where to from here?
Divide by -2.
Yep. Good. And then?
Take the square root.
Yep. Sorry. Yeah. So what do I have on the left side though?
Just 2.
So 2 equals, and the right side?
X plus 3 squared.
Yep, exactly. And where to from here?
Now you take the square root.
Yep. And what must I be careful to do when I take the square root on both sides?
Plus or minus.
There you go. Beautiful. Excellent. So, and then continue?
So then you would have to move the 3 over.
Yep. So what do I get?
So 3 plus or minus the square root of 2 equals x.
Yep, I think you're like speaking softly, but -3, yep, plus or minus the square root of 2. So there are 2 x-intercepts. Obviously, we got here by making y 0. So one of them is -3 plus square root of 2 comma 0. The other is -3 minus the square root of 2 comma 0. Fair?
Yeah. Can
Okay.
you hear me any better?
Sorry, yeah, you're good. You're good. Don't worry.
Okay.
You have a voice with enough authority that like even if you talk like me, I sound like I'm screaming, but like you, but you like just have the right kind. Anyway, like yeah, okay. So like the graphs, like I'm pretty sure that if I ask you to graph this, you would know how to graph it. Because like as I said, was happy with how you did with the graphs to come later. But yeah, transformationally, what happened is like, well, tell me the shifts that have happened on this graph, like from problem one.
Okay. So to the right 4, right?
Mm-hmm.
Or wait, is that up 4?
Up four, uh-huh.
Yeah, up 4. And then so if it's plus 3, then is that left and right?
Yep. Is it left or is it right? You tell me.
It would be left, right?
Yes. And the squared quantity, if it's plus, it's to the left. If it's minus, it's to the right. Also, this is very, very crucial, but like, so I'll like say a few things like this, like that I want you to remind. I'll just hint you with saying crucial. These are like the tricky things that I need you to remember and like imprint my voice in your head. And so this is crucial, which is when you do transformations, you have to do HSRV. So yeah, you have to do horizontal first. This is the order, and then reflect and vertical. So you have to do it in this order. So if when we're graphing this function, we first do take care of the horizontal. So we know it's at to the left 3, so it's going to be at -3. Okay, and then we have to do the reflect, and it's reflected over the x-axis, fine. And then we have to, so it would have looked like this, and then HSRV. We have to do the stretch also, but the stretch is like before the reflect. Don't worry about the stretch. So the stretch is like the 2. It makes it narrower. Now I'm saying this like in case you have like a question. Like the ones in your handout where your teacher asks you to verbally describe. Because otherwise you pick numbers, you plug in numbers to graph it, and I really like that because it's worked for you consistently on everyone. So you could just stick to that. But just keep this as like, important information. So like between 1 and 2 is stretch. The stretch is the fact that we have a multiply by 2 in front of the parenthesis. So what that means is like usually a parabola is like, simply x squared, the parent quadratic, would be like at 0 it's 0, at 1 it's 1, and at -1 it's 1. But because there is a 2 in front of the parenthesis, which means it means that at 1 it's up 2 instead of 1 over 1, and then at -1 it's up 2. That's just a parabola if it was not reflected, blah blah blah. So if it was just 2x squared, it would be narrower than the typical parabola. So technically after the horizontal you're supposed to do the stretch. So just like have this imprinted in your head. Crucial, crucial, crucial. So like, if I move to the left of -3, what I'm gonna find is -4. Well, at -4, instead of going 1 down, it means that I have to go 2 down because of that 2 in front of the parenthesis. So this is -2 right here. Now, because you've already mastered all the other basic / medium stuff that we have discussed, you could like, keep that like in your head and just add this like the stuff that I say is crucial as like the new thing that you must pay attention to. All right, and you already know this stuff too. It's just reinforcement. Anyway, just like moving to the left from -3 puts us at -4. If we move to the right, it puts us at -2. And so at -2, instead of going 1 down, we go 2 down. So then the points that you have are the ones in red, right? So far, that is. Because, well, there's one more transformation. We took care of the stretch, that's the 2 in front of the parenthesis. We took care of the reflect, which is the negative sign in front of the whole thing. And then the horizontal, which we had to take care of first. We already did that by shifting the graph to the left. And so the only thing we have left to do is the +4, which is up 4. So that means that like this whole thing is going to be moved up 4. So really the graph is going to look like the same graph that we have in the dotted version. So you can move the points where they need to be, like, but up here. Like, everything makes sense?
Yeah.
Okay, and we don't need to have like this thorough discussion on the rest of it. I intentionally like, dwelt on this. All right, cool. So let's go on to problem 2. So we should be able to finish this and the review packet within an hour. Okay, the rest of this stuff is just talking his butts. Anyway, problem 2. Okay, so problem 2, very, very happy, like with like all of your work pretty much. So A, like correct, excellent. And I was particularly proud of how you found y, which is by plugging in the value you got when you did minus b over 2a. That was -3. You plugged that into the function and you got 1, and you calculated all that correctly. I was also equally happy with what you did with b. It says maximum. So does the function have a maximum value? And you said 1. Yes, that's right. And is that 1 a y or an x value? Just
Y.
exactly. Beautiful. And then for D, it says state the domain and range. And I'm sure you would have like been able to graph it successfully. Like, sorry. So on the graph, like you picked out the vertex, which is negative. This is the standard form, right? Obviously not the vertex form. So like once you figured out the point -3, 1 is on it. So once you have -3, 1 is on it. Like how would you have finished the graph? I'll come back to the domain and range, but how would you have finished the graph?
I mean, what I tried to do is I just tried to plug in 0 for x.
Yes, exactly. That's what I would have advised, because 0 is a cheap point. When you plug in 0 for x, what you're going to get is -8 right here. But then that means from the vertex, which is at -3, you went 1, 2, 3 spots to the right to find -8. Meaning, since we know a parabola is symmetric about the vertex, if you move 3 spots to the left, which is at -6, then you also get -8. So the 3 points you have are these 3 points. So you go like this, and like this, and you're done. So that's how you would, this is the most efficient way to graph when you're given the standard form, which is to identify the vertex, which I already know you know how to do, and then immediately plug in 0, and then mirror that on the left, and you're done. Does that make sense?
Yeah.
Okay, what about the domain? We know for all quadratics is -infinity to infinity, so very well done there. For the range, almost correct. It's almost perfect. I want you to make one minor adjustment for the range. What do you think that is?
Is that the square bracket at the end?
Exactly. At 1, you need a square bracket. So I'll write it. So it's -infinity, comma 1 hard bracket right there. Make sense?
Yeah.
Okay, cool. Now, these two next questions, 3 and 4, are like basically at per your request. You asked for these. And like since I kind of messed up on my explanation to you last time, it's yeah, useful that you did. Okay, so like first you set up beautifully, even though I didn't tell you the A, B. You said X is one of them, so first, and then Y is the other. So good choices of variables. And then you also said P is equal to X times Y. That's correct. Now we need to turn this P equation into a variable just about X. So we need to make a P equals in terms of X. And so there's a bit of information we have not used so far that would allow us to do that. What do you think that is?
Yeah, I don't know. This is where I get confused.
It's okay. It's okay. So, so the P you got P equals X times Y you got from the product part. But what was said before that?
That their sum is 7.
Exactly. What does sum mean?
Addition.
Yeah, so turn that information into a mathematical equation. What would it say?
X plus Y equals 7.
Exactly. X plus Y equals 7. Okay, so then now from this equation, get Y by itself. So what would I have to write?
Y equals 7 minus X.
Exactly. Beautiful. So then now come to the P equation and get rid of Y by substituting what you found when you isolated Y, which is 7 minus X. Now distribute, meaning distribute this X here and there. So what do you get P is?
7x minus x squared.
Exactly, and we like leading with x squared, so we're going to go minus x squared plus 7x. Okay, cool. So then to answer the question, it says find the pair of numbers. So to find the pair of numbers, for the one of them, for x, just do minus b over 2a. This is the part where I messed up. So the way you find it is just do minus b over 2a. once you get the p equation to be all in terms of x. So then what is that going to say?
-7 for b. So like negative and -7. And then -1 for a.
Yeah, so -7 over 2 times -1, which is going to say -7 over -2, which is?
Like as a mixed number or decimal?
Sure, we can leave it like this. Just cancel the negatives. I'll say it, sorry, because I know you know it. Just positive 7 over 2. Now, this is x. One of them is positive 7 over 2. Remember, we isolated y earlier. So then we can use that equation to find out what the other number, y, has to be. So it's 7 minus 7 over 2. So y is going to be 7 minus 7 over 2, which is?
So I'm trying to think of what 7 over
It's
2
okay.
is.
It's okay.
That's like 3.5, right?
Yeah, exactly.
Okay. So y would equal 3.5.
Yeah, exactly. Y is also 7 over 2. So it's just the question made them the same number, and that's perfectly fine. Don't panic if that happens on your question also. So both of the numbers are 7 over 2. That maximize the product given that their sum is 7. Make sense?
Yeah.
Okay, cool. So now you talk through this next question. Talk to me.
So I guess this time you have to minimize it, right?
Yep.
So...
Sorry, real quick. So if we had to maximize it, we needed a parabola that faces down, which means at least with a negative, and that's exactly what we found. Our equation for the last parabola was like -x squared plus 7x. So you don't have to worry about whether or not your quadratic is going to end up that way. In fact, I said use it as a way to check your work. If it says maximize it and you don't have your p equation doesn't end up being like a parabola that faces down, then you did something wrong. So check your p equation. This time, as you said, we have to minimize it, meaning our parabola is going to face up, meaning that the x squared is going to have a positive in front of it. It may be positive 1. Anyway, go ahead.
Okay, so I guess to make the p of x equation, you could do x minus y equals 10.
Yep, exactly. X minus y equals 10. And?
Then isolate y.
Yep, go ahead.
So that would be y equals -10 plus x.
Let's see, is that right? Yes. Yes, y equals x minus 10 or -10 plus x. Same thing. And then?
And so then you plug that in for y in the original p of x equals x times y.
Yep, exactly. Beautiful. So see, we like what appeared to be even difficult for me now we've made very simple. Excellent. So yep, here you go. Talk to me. Continue.
So then that would be if you distribute the x.
Yep, beautiful.
With x plus x squared.
And then?
I do negative b over 2a, right?
Yep.
So then that would turn into positive 10 over 2, which is 5.
Yep, exactly. And what do I do with this 5?
Do I take it away from -10?
Exactly. Use it in the equation where you isolated y to find. So you go y equals 5 minus 10. So y is equal to -10. Make sense?
Yeah.
Sorry, I did that poorly. I was checking if you're 5 minus 10, -5. So one of them is positive 5, the other is -5. Okay, I think like you've owned these questions. So should we get a question like this on your test? It'll just be an easy layup. All right, cool. I was very, very, very happy, delighted at your work on 5, and this is what I was talking about. You should understand it transformationally, which I'm pretty sure you do. So real quick, you took square root of x, which looks like this, right? It's like a sideways parabola, but on one half of it. So that's f of x equals just simply square root of x. What had happened is, well, you have negative square root of x minus 2, so look on the whiteboard. So that's been shifted to the right 2, because it says x minus 2, and we know when it's inside, it's the opposite. And then it's reflected because of that minus sign in front. So your final product should be what I'm drawing in green. So whatever is easier. If it's easier to plug in the numbers and get what you got, that's perfectly fine. But obviously what I have in green looks exactly what you have. But what I was even more happy about is the way you answered your domain and range questions. Like you got your parentheses, hard square bracket versus soft bracket, spot on. So excellent, excellent work. Okay, sorry. And then so let's we can quickly move past that. And so let's go to part B. And part B, like I checked your work. It's good. Now you plugged in 0, 0, 1, 1, and when you plug in 1, you get 1. Close. So it's okay. So this is what we could do here. So look at g of x. So g of x equals, sorry, how tired are you?
Not that bad.
Okay, no worries. Like we'll make this nice and like quick. Sorry, we'll try to make it that way. Okay. Anyway, so look here. So again, this is how you can graph. Like so, if in this kind of a question. So start with the parent function. This is simply the square root of x. Look on the whiteboard. So it's what I just drew in red is simply the square root of x. Now we have to remember HSRV. And in fact, I got this from Miss Richardson at Hackley. It's horizontal, stretch, reflect, vertical, and she calls it Hackley students ride vans or some shit like that. Anyway, yeah, it's HSRV the order. So we have to do horizontal first and then stretch blah blah blah. So we start with the horizontal. Since it's inside, it means it's to the left one. So we take it to the left one. Now, the one in red, it would have been like 0, 0 would have been a point, and then 1, 1, because the square root of 1 is 1, is another point. And then we got to go to 4, and then it's 4, 2. Like, so 4, 2 is an additional point. So here we are. Now, so we move all these. You don't have to pinpoint all of these when they've been shifted to the left. Obviously, when you move them to the left, only their x changes, so you'd only have to shift all of the x's by 1. But it's okay, you don't have to put them on there. So the casual, like, blue graph I drew is sufficient for our purposes. Now, what we do from there is we took care of the horizontal, right? The stretch. The stretch is the 3. That means that, like, well, actually, let me write them. So 0, 0, after the horizontal, 1 becomes negative 1, 0. And then 1, 1, after the horizontal becomes 0, 1. Because we're moving all the x's to the left one. And then, 4, 2 turns into 3, 2. Got it. Now, we have to multiply by 3 because of the stretch. What that's going to multiply is only the y values. So the y value 0, well, 0 times 3 is still 0. The 1 turns into a 3. And then the 4, 2, which was moved to 3, 2, the 2, once we multiply by 3, is going to turn into 6. So these are the new points, and now we have taken care of that 3. That's a stretch. So we took care of the stretch. There is no reflect because there is no negative in front of the thing. And so the only thing we have is the vertical. The vertical is going to affect all the y values. So the last thing we got to do in green is move all the y values up 1. So 0, a y value moves up to 1. 3 moves up to 4. And then 6 moves up to 7. So the new points are negative 1, 1, and then 0, 4, and then 3, 7. So we could either plot these, or you could either plot these, or if you want to do what you did, it's perfectly fine. But like on your table, here, these are the numbers I would choose for x. 0, well, because that's going to give you 3 times square root of 0 plus 1, that's this, so that's 3 minus 1, which is 2. So at 0, we should get 2. Well, we have to subtract 1 from it, right? No, there's a 3 also. Sorry, what am I doing? Yeah, sorry. So when we plug in 0, do we get... Yeah, I'll do it your way, my bad. So I'll, like, I guess hopefully, like, the transformational talk I gave you is helpful, like, again, if you're given a verbal question, but I'm going to do it your way. So I'll just, because it's working for you, and it might be the easiest way to attack these. So sorry. So x plus 1 minus 1. So on the table, plug in 0. If we plug in 0, what do we get? 3 times square root of 1, because 0 plus 1 is 1, minus 1. So that gives us 2. Okay, so maybe Miss Richardson lied. Anyway, sorry, that's just me like bailing myself out. So 2. Okay, and then the next point we plug in, like, right? So after we plug in 0, what number do you think we should plug in?
I guess you would want to do something that would simplify the radical.
Yes, yes, beautiful. So what number would make the radical work out very nicely?
8.
Yes, but something before 8. 8 was the last one, the third one I was going to ask you to plug. Before that. Huh?
3.
Yeah, beautiful. 3. Bingo. Like, yes. I'm like so happy with you. Like, you're smart. Okay, cool. Sorry. Yeah, so 3 times square root of 3 plus 1 is 4 minus 1. So that's going to say 3 times 2, square root of 4 is 6 minus 1, which is 5. So 3, 5. And then the last one is exactly as you did, 8. That'd give you 3 times square root of 9 minus 1. That's 3 times 3, which is 9. So that's 9 minus 1, which is 8. So 8 would go to 8. So you just plot these, and that's good enough. Now, if we plot these, well, okay, sorry. Well, I guess the transformational stuff would work, would help us also now. If you plot these, it will give you an accurate graph. But for the domain, remember there's a square root involved. What's the smallest number that I can plug into this? G of x equals 3 times square root of x plus 1 minus 1. What's the smallest number that I can plug into this?
0.
How do we find the domain of anything that has square root in it?
Well, it can't turn into a negative number under the square root.
Exactly. Sorry for interrupting. Yes. Sorry, exactly. So you take, so let's say you have square root of stuff. What you do is take stuff and set it greater or equal to 0. And I know you know how to do that because you did it on a problem to come. So set x plus 1 greater or equal to 0. So then that gives us x is greater or equal to what?
Negative 1.
Exactly. So technically, we could have started, instead of, on our table, technically we could have started with negative 1. Because when we plug in negative 1, it's going to give us 3 times the square root of 0 minus 1. That's 0 minus 1. So a fourth point, if we so chose, would have been negative 1, negative 1. But we would have gotten that by plugging in negative 1 for x. So that, because that's the smallest x we're allowed to plug in. But, you know, plugging in 0 and then choosing the other one strategically as you did is good enough for me. Now, but it is very helpful to figure out, you know, how to set the inside greater or equal to 0 for domain purposes. So that now, for the domain, you answered it correctly. You said, but you wrote infinity negative 1, hard bracket. But start with the negative number, the smaller number. So the way you should answer it is negative 1 to infinity. And again, if you needed to figure out what that smallest number is, it had to be negative 1, take the inside of the square root and set it greater or equal to 0. Fair?
Yeah.
Okay, and then from your range, like for your range, that part we need to fix a little bit. So the smallest x you can plug in is negative 1. So plug in that smallest x. So the g of negative 1 is going to say 3 times the square root of negative 1 for x plus 1 minus 1. That's going to say 3 times the square root of 0 minus 1. So then this is going to say 0 minus 1, which is negative 1. So this is a y value. So the y also is going to start at negative 1 and end up at infinity because the trajectory of your graph is correct. It's going to go up. It's not shifted over the x-axis, so it's not gonna look like this. It's going to look like that, so it's going to go up to infinity. So the range is also negative 1 to infinity, where we include negative 1. Make sense?
Yeah.
Okay, cool. Sorry. All right, thank you. Cool. So absolute value graph, beautiful. Don't have to say anything here because you did it flawlessly. Just do exactly what you did here on your quiz, and I'll be happy. Okay, cool. Now for problem 7, like the problem 7, the first one is like a little trickier than anything I saw on your review or on your quiz, but I intentionally did it to cover all our bases. So the function we're looking at is f of x is equal to 2x over square root of x minus 2. Now, when we see something that has square root of stuff, what did we say to do?
So not equal to 0.
Yeah,
It's
set.
greater or less.
Yeah, sorry. I'm sorry. Go ahead.
Yeah, no, that's it. I don't
Okay.
have anything else.
It's okay. It's okay. So what should I set greater or equal to 0?
X minus 2.
Exactly, and it doesn't matter that it's in the denominator. Anywhere you see a square root quantity, take the square root quantity and set it greater or equal to 0. So when we do, we're going to get x is greater or equal to 2. But one exception, the square root quantity is in the denominator. What are we not allowed in the denominator?
0.
Yeah, so anything that makes it 0 is not allowed. And what would make it 0 is that 2. Because if we do in the denominator 2x over square root of 2 minus 2, we're going to get 0 in the denominator. So you have to consider both things because the square root in the denominator. You have to consider what you have to do when you deal with a square root of stuff, but you also have to consider what you have to do when something is in the denominator. So the way you'd adjust your answer is get rid of that equal to part and say x is strictly greater than 2. Does that make sense?
Yeah.
Okay, cool. So that one was a little bit tricky because of this. All right, great. And then g of x, the second one, you did a beautiful job. And what I said last time, and I repeated this question from our quiz discussion, last week or whatever, because it showed up on your review packet, and I wanted to mimic it. And what we said is if you have more than one square root quantity, set both of them greater or equal to 0. So x plus 2 is greater or equal to 0. X minus 3 is greater or equal to 0. And when you do, the second one says x is greater or equal to 3. The first one says x is greater or equal to negative 2. And take the more restrictive of the two. So what's more restrictive? X is greater or equal to negative 2 or x is greater or equal to 3?
Negative 2.
Let me draw a number line. So if we say negative 2 is here.
Yeah, sorry.
It's
negative,
okay.
not
Yeah, it's okay. It's okay. So the first one of them says you can cover anything to the right of negative 2. The other says you can cover anything to the right of 3. So the more restrictive one is this one. So draw a number line if you need to be careful to do these. Again, you don't have a time issue on your test. In fact, from my understanding, you finish a little bit early. So take that time to do extra things like these to make sure that we avoid careless mistakes. But otherwise, I know you know how to do this. In fact, the only reason I'm discussing it is because your answer is correct, but you didn't show any work. So that's the only reason we're talking about it. All right, cool. So next one is problem 8. So for problem 8, it says f of x is equal to, it's x over x minus 2, and then g of x is 2 over x. G of x is equal to 2 over x. Now, for f of g of x, I mean, you know how many, you have no idea how many kids, even Hackley, struggle with this idea of composition. So I'm very, very happy with how quickly you owned it, and your work is correct. I'm just going to simplify a little bit more than you did. Okay, now, so f of g of x would be plug in g of x everywhere we see an x and f. So then this is what you wrote, 2 over x over 2 over x minus 2. But don't have the itis, simplify. 2 over x over, sorry, 2 over x, and then if we multiply this second one by x over x, it's going to say minus 2x over x. Now we have a common denominator, so I'll do this very quickly. So then simplifying, it's going to say 2 over x over 2 minus 2x all over x. And now we have a fraction divided by a fraction, so we do the keep flip change. So 2 over x, and then it's going to say times, change the division into multiplication and flip the other guy. So that's going to say x over 2 minus 2x. Now, so then we cross this x and this x out, and so we're going to get 2 over 2 minus x. 2 over 2 minus x. Now I'm rushing. There's a 2 in front of this. Now in the denominator, we can factor out a 2. So we're going to write 2 over 2 times 1 minus x. And we can cancel. Sorry, say that again?
No, I realized I'm wrong.
It's okay. It's okay. So 1 over 1 minus x is where you're going to end up with. And I know if I asked you to simplify, you'd be able to simplify correctly. Simplify, if you get a similar question, chances are you're not going to get something that it has this much gymnastics on it. But if you do, we've discussed it, so you have a way out. Now, crucial. I said I'm going to say crucial a couple of times in this session. Crucial is this. And this was, even when I was a teacher, this was a tad bit tricky for me. It's not that tricky. I don't know why it was tricky in my head. But anyway, like crucial is this, right? Which is like for domain of FOG, it's asking you for the domain of the composition. So it's asking for the domain of f of g of x. So it's asking for the domain of this guy at the very end. You have to do two things in order. The first is you have to find the domain of the function you plugged in. That's the domain of g of x. That you did correctly. You said all numbers, well, actually, you simplified correctly in the end and you wrote 1 minus x. So first, you have to look at the domain of g of x. G of x is 2 over x. What are we not allowed in g of x?
0.
Yeah. So you have to, number one, start with what you're not allowed to plug in the function g of x and the one you plugged in to f. So x is not 0. And then, like, you do all this work and you end up with where we ended up, like on your paper, good job, 1 over 1 minus x. That's correct. So from there, you were correct. X is not equal to 1. But both have to be reported. Both what's not allowed into g of x and what's not allowed into what you ended up with at the very end in the composition. Great. So that brings this review of this test to a conclusion. Again, like, I'm very happy with your work all over. So let's move on to the test review. Now, on your test review, like, what kind of did you do this? Did you fill this out on your own? Did you guys fill it out in class? What happened with this?
I think, yeah, in class we did like 1 or 2 problems. I think it's not like homework or anything. It's kind of just extra stuff.
Okay. How should we deal with it, you think?
Let me take another look at it.
Okay. I mean, it obviously has a repetition of some of the things that we just talked about, so there are places where we don't need to repeat things, but there are places we must discuss some things. And so...
I'm looking at it now.
Okay.
Yeah, I think like we did stuff on the first and second page already.
Okay.
This is all domain stuff on the third page.
Okay, so I'm not gonna do every question, but I'll pick and choose questions to discuss with you. So I'd hate to like, keep going on, but let's talk about some items. I'll pick for you, and if you get it, just be like, I get it, move on. Okay?
Yeah.
Okay. So for the I'm gonna start with I'm gonna skip A and I'm gonna go with the h of x function. Yes, we just got done graphing it, but I want to reinforce it. Anyway, what are the instructions for this?
What number is it again?
This is the very first one, part B.
Okay. It says use transformations of the parent function to graph each of the following. State the domain and range.
Yeah. So talk to me. So how do we do this? How is it transformed?
So I guess with the acronym you would start with horizontal. I think.
So which way horizontal?
Left one.
Yep.
And then is it SRV, the acronym?
HSRV,
What's the S stand for again?
Stretch. It's okay.
So then that would be 2, right?
Yeah, exactly. So what does that do to the... So obviously the parent function is x squared, which again, very quickly, would have been at 0, 0, 1, 1, blah, 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 negative 1, 1. Okay. So what does that 2 do to it?
It, like, stretches it out 2 more.
Yeah, so instead of going 1 to the right and up 1, we go 1 to the right, up 2. So it's right here, 0, 2, and where else?
Like horizontally, I don't know if that makes sense.
Well, yeah, so it's going to mirror over the vertex, where the vertex has been shifted to -1. So I have 0, 2. What else is a point on the parabola so far?
Um, would it be -1? Um, just -1, 0, or
Well, okay,
yeah,
sorry. It's okay, it's okay. So we took 0, 0. By our horizontal shift, that became -1, 0. And then I'm saying that 2 right there, what it does is instead of on the usual parabola, you'd go 1 to the right from 0, 0 and have 1, 1. But that 2 is going to, instead of going 1, 1, it's going to make it 1, 2 and -1, 2. So I said, well, now that our new location for the vertex is -1, we go 1 to the right up 2. So what else do we do to mirror that?
so like 2 to the left.
Yes, -2, 2. So from this new vertex, which is at -1, 0, we go 1 to the right and up 2, but then 1 to the left and up 2 also. Make sense?
Yeah.
Okay, cool. But now we took care of this stretch, horizontal stretch, and then we have to take care of the reflect. So the reflect is going to make it do this. Well, what that means is right here, I have this point and this point. What are these 2 points? I'll highlight them in blue, right here and right here. What are those 2 points?
So wouldn't that be um 0, -2,
Yes.
and -2, -2?
Yes, beautiful. But then finally, we just took care of the reflect, and obviously -1, 0 stays where it's at when we reflect it. We have one final shift, and that's the up one, +1. That's the vertical, and all that's going to do is add 1 to the y values. So the final coordinates are going to be like right here, and right here. What are those 3 coordinates? And I'm running out of color, so I'll do it in red. Right here, and right here. What are those 3 points?
So the first one would be -3, -1.
Yep, exactly. Beautiful. I'm satisfied. And then
Then the second one would be -1, 1.
I'm done. Okay, that's good enough. All right, we can keep it moving. All right. So, um, sorry. Um, so the next one is I'm gonna go to D. So 1D. So g of x equals how many tests do you usually have per quarters?
Mm, um, I don't know. We probably have one like in math, not often.
Okay.
I'd say
Okay.
every like 3 or 4 weeks.
Okay. That's why I'm dwelling on this. Okay. Anyway, what is it like? So is the semester like first of all, are we in the third or second semester, and when are we approaching the end, or where are we?
So we're in the second one, and I think the end is either late February or early March. So
Okay.
yeah,
All right. That's what I thought. So let's like end with a bang, keep that A, and I'll be like a very happy man. Okay. All right. So now, obviously, the parent function to this is what? What's the parent?
I think that one is just 0, 0, 1, 1, and then 4, 2.
Yes, exactly. It's this guy, the square root function, square root of x. Great. Now, we already talked about how we're going to deal with this. Yes, I'm sure you understand the transformations. This is a stretch. This is a horizontal shift. This is a vertical shift. But I don't want you to do that to do it that way. We said that we're going to create a table for these x and y. So in the table, what is the number that you should? What number should I pick?
I guess you could do 5.
Yep, exactly. So first, since we probably have to answer the domain question. Oh, by the way, like I'm sure you know how to answer the domain of a parabola and the range. The domain is all real numbers, blah blah blah. The range, you just look at the graph. I'm sure you can negotiate that on your own. But since we have to answer, I invariably have to answer the domain question, let's start there. How would we find the domain of this?
I mean, sorry, I'm just going back to the
It's
whiteboard
okay.
for a second.
It's okay.
Um, okay, so, well, the domain is all the x values.
Yep. So how would I figure out what that is in this kind of a function?
So wouldn't it just be 1?
Yeah, so take the inside, exactly. Take the inside, x minus 1, set it greater or equal to 0. That's going to say x is greater or equal to 1. So the smallest x you can plug in is what?
1.
Exactly. So start there. It's not that your 5 was incorrect. 5 was a beautiful pick. But since we always have to answer the domain question in these questions, first do this. Take the inside of the square root, set it greater or equal to 0, figure out what that smallest x is, and so on your table you can start with that one. So we start with 1, and then 5, and then give me one more.
10.
Sure, that's right. These are all good numbers. So I could do it. So 2, because I know you know how to do it. So that's gonna be like what? Maybe you can help me. Sorry, 4, 6, and then 10 is 9. So that's 3, 8. Okay, got it. Now we take these and what do we do with them? Sorry, we plot them. So we have 1, 2, okay, right here. 5, 6. So this is 1 and this is 2. 5, and then 6, 5, 6. That's right here. And then 10, 8. Okay, 10, 8, like somewhere abouts here. So it's going to look like this. So tell me the domain.
Isn't it just 1 comma infinity, I guess?
Yes, 1 comma infinity, and then a hard bracket at 1, soft bracket at infinity. Range?
2 comma infinity.
Yes, bingo, beautiful, very well done. Okay. All right, so the absolute value functions, I feel like you're very good at them. So I don't know, that we need any discussion. I felt like you did very well with like the one I put on your quiz, and obviously I knew to do that from here. Now, so for E, like real quick, like I'll just do it very fast, and I'll be the one talking. So y equals absolute value of x plus 4 minus 2. We all know, or not all, but you and I know absolute values of v. So we take care of the horizontal first because that's the order. There's horizontal mean to the left 4, so this is a negative 4. And otherwise it's a v. Usually the v is like you go 1 to the right, up 1, 1 to the left, up 1, otherwise 0, 0. And there's no number in front of the absolute value, so there's no stretch to take care of. So this one is going to behave the same way, which is from negative 4, we move 1 to the right. So at negative 3, we go 1 up. And then 1 to the left at negative 5, and we go 1 up. There's no reflect, so there's no stretch. There's no reflect. And so the final one is the vertical, and that's down 2. So you move all of these points down 2. It's going to look like this. The domain is just like quadratics for absolute value. It's negative infinity to infinity. That's the domain. The range, go off of your graph. So from your graph, it looks like it's shifted down 2, so it starts at negative 2. That's the lowest y we see, to positive infinity, over. Okay, cool. And look at G real quick. What does G say?
F of x equals x cubed minus 2.
That's right. Now, look here. So for anything that, for anything that has x cubed in it, so if you have an x cubed function, what you need to do is you need to create a table. I want you to do it using the tables as you always do, but you need to create a table that's symmetric. So meaning like if you're going to plug in negative numbers, if you're going to plug in positive numbers, plug in negatives also. So plug in like negative 2, negative 1, 0, 1, 2. And you put, figure out what the y's are, plot that. And for x cubed, or any transformation of it, like x cubed minus 1, it's going to look like an elongated s like this. And if it's reflected, which is it has a negative in front of it, it's going to be an s also, but it's going to look like this, like it's reflected over the x-axis. It's mirrored over the x-axis. But my point is that for x cubed, anything involving x cubed, use negative values and also their positive counterparts, and obviously 0, and do it by plugging in numbers as you always do, and do it successfully like that. Great. All right. So that means that, we're done with the graphing. So read problem 2.
If the function f of x equals the square root of x is reflected over the y-axis, then moved down 3, what would the new equation be?
Okay, got it. So you're going to help me with this. All right, so I'm sorry. I guess we have to read it slowly. So what is it? The function squared. Okay, so the parent function is square root of x. Okay, so take one transformation at a time and tell me what happened.
So if it's reflected over the y-axis, then the whole thing is negative.
Yep, so you start with f of x is, well, I guess it's a new function, so we can call it g of x. G of x negative root, okay, root x right now, and then incorporate the other info.
Moved down 3, so that would be, down 3 would it be outside?
Yes. And it's exactly as it says, down minus 3. If it was shifted to the right right 3, sorry, it would have been like this, and to the left 3 it would have been like this, blah blah blah. But you're right. I'm really glad that you inserted the crucial word there, which is it outside? Yes. So it would just be negative square root of x minus 3, just in case I move too quickly. All right, that's it. Okay, on to the next one. So for 3, find the domain, blah, blah, blah. We know all of them, most of them. So we're not going to do A or C or some of them, or F, blah, blah, blah. Or H, because we did a similar one. But we're going to do 3 of them. So for B, it says, so you need to find the domain of g of x equals, and then what is it? 3x over x plus 4. So what is the domain of this?
So I guess the denominator isn't allowed to be 0, so wouldn't it just be all real numbers except for negative 4?
Yep, exactly. All real x not equal to negative 4. Exactly. Okay. And good job. And then what about for D, which says f of x equals square root of 6 minus x? What about for this one?
So I can't be a negative number in there. So.
Yeah, so just on your brain, just make it automatic, make it a reflex. Take the inside, set it greater or equal to 0. When you do, it's going to say, if you add x to both sides, it's going to say 6 is greater or equal to x. If you add x to both sides, right? And so then I always get a little confused here. Reorient it so that the pointy end is still pointing in the direction of x. That means x is less or equal to 6. So this would be your final answer. Does that make sense?
Yeah.
Okay. And my bad about writing the 6's. Well, actually, I wrote them 4 times, so we're okay. Just a dumb superstitious note. Okay. All right. Good. I like that in the end I got that a nice little giggle to yourself. So good. 2x minus 1 over and then it's x squared minus 4x. What about this one?
So when you just set the bottom equals 0.
Yeah, bingo. X squared minus 4x equals 0. Talk to me. Continue.
So then I guess you could just divide everything by x, right?
Let's factor. I got you. I'll do it. Factor out an x. You're going to get x times x minus 4 equals 0 from this.
Then you can... Sorry, you can divide by x.
Don't divide by x. So you have something times something equals 0. Either of them could make it 0. Don't worry. X equals 0 or x equals 4. These are the 2 you exclude. So you'd say in this case, all real. I know you'll retain it. I'll say crucial. So this is the 3rd time I've said that. So you remember the things where I've said it. But yeah, all real numbers, x, not 0, and not 4. Make sense?
Yeah.
Okay, great. All right, so G, and this is just me being super paranoid. I said I wasn't gonna do it, but I'll do it because I'm a paranoid human being. So x plus 7. Okay, so take the inside, set it equal to 0. So the first one is gonna say greater or equal to 0. X is greater or equal to 1, and the second one is x greater or equal to negative 7. The more restrictive is x greater or equal to 1. So the domain for H is all x is greater or equal to 1. Yeah, or if you want to do it the other ways, 1 comma infinity over. Okay, good. All right, so we're moving through this pretty efficiently. That's good. Now, unless you tell me otherwise, Julia, we did a very similar problem to 4 when we were going over your mock test, and I feel like you got this. So do I need to do 4?
Mm, no.
No. And again, just as a quick reminder, when it's asking you for the domain for part B of 4, what you have to do is look at G and see what you need to exclude from there. So that's obviously 0. And then you got to put G into F, simplify, look at that, see what you need to exclude from that, and couple both and leave out whatever is not allowed in both of them. So that's a succinct summary of what we said. Okay, all right, 5. And 5 it says, one sec. M5 it says f of x equals and then it's 2x cubed plus 1. Yep. And it's asking you to find f inverse of x. So talk to me. How do we do that?
Could you repeat that? Sorry.
Yeah, sure, it's okay. So we need to find f inverse. So talk to me. How do we do that?
So you swap the x and y.
Yeah, we go y equals 2x cubed plus 1. Swap. So talk to me. You talk.
So wouldn't you just yeah, I'm trying to think. Wouldn't you just like
You got it. You told sorry, go ahead.
don't you just want to like isolate y?
Yeah, so the first I didn't swap x and y even though you instructed me, so I'll do that first. And then yes, you're right. You isolate y. So help me do that.
Um oh sorry, yeah, I thought they were already switched for
It's
some
okay. It's
reason.
not your fault.
Um okay, so then you could move the 1
Yep,
over
minus
to
1. Yep. So you get x minus 1 is equal to 2y cubed. Talk to me. And then
um and then divide by 2
yep.
and then take the cube root.
Yep. X minus 1 over 2 equals y cubed. Beautiful. So take the cube root. So cube root of x minus 1 over 2 equals y, but then it's not y, it's f inverse. We finally name it f inverse and done. And what we said is if you put these into each other, you're supposed to get an x. Because I'm not going to review that, like if it comes up, which is plugging them into each other and, seeing that we get an x, I'm going to do it right here. If my pen would stop messing with me. Okay, so, all right, so here it is. So if we do f of f inverse, so this is what you were asking me on text, f of f inverse of x would be like, it would be like 2 times, and then we plug in cube root of x minus 1 over 2, and then cube that plus 1. All right, if we simplify that, we get 2 times. The cube root and the cubing get rid, so we get 2 times x minus 1 over 2 plus 1. And then the multiplying by 2 and dividing by 2 get rid. So we're in the next step, we're going to get x minus 1 plus 1, which is x. We're done. We've verified that we found the correct inverse. Fair?
Yeah.
Okay. And then what about 6?
Well, I guess isn't a one-to-one function like I guess there's 2 requirements. I think one was that it has to pass it's a horizontal line test,
Yeah,
right?
exactly.
I know the other one's on the tip of my tongue.
No, you're good. I think that's it.
Oh, okay.
Yeah. So what would you say about 6? Is it 1-to-1?
Well, you need to find the inverse too, right?
Well, you can't find the inverse if it's not 1-to-1. The only thing you have to do in this question is answer if it's 1-to-1 and say why.
So I guess if you have to figure out if it passes the vertical line test.
The horizontal line test, as you said correctly. Yeah, now, it's okay, so good. It's late, you're getting tired, I'm getting tired too, but it's okay. I'll push on, we don't have much left. Okay, now look here. So, you have an absolute value function. What does that look like when you graph it?
It's like a V shape.
Yes, so if it's a V shape, unless you say x is greater or equal to a certain number, look at 7. You see how like a parabola doesn't pass the horizontal line test. But notice, look at number 7. Notice it says x is greater or equal to 0, right? On the parabola.
Yeah.
So that makes it like 1/2 of the parabola, so it passes the horizontal line test. So, but in 6, the V, it doesn't say that. It doesn't say x is greater or equal to 1. The V, the sharp part, would happen at x equals 1. And it doesn't say that. Therefore, a V doesn't pass a horizontal line test. So you should say it's not 1-to-1. And your explanation is that, well, it doesn't pass a horizontal line test because it's V-shaped, and a V-shape doesn't pass a horizontal line test. Make sense?
Yeah.
Okay, cool. Let's move on to 7. So it says verify that there are inverses, because I feel you like understand graphing both types of functions. I'm gonna do it so that we go through it efficiently. So real quick. So like first, x squared minus 4. That's easy. We've graphed much harder functions. It would look like this. Shift the parabola shifted down 4. But it says x is greater or equal to 0, so it passes the horizontal line test. So we got to get rid of that part. Got it. And then, so this is the quadratic. And then its inverse is square root of x plus 4. That's a square root function, which I know you know what it looks like. Shift it to the left 4, because it says x plus 4 inside. So that's going to look like this. And what inverses are supposed to do graphically is they're supposed to mirror each other over the line y equals x, and they do. Fair?
Yeah.
Okay, so we've done the graphically part. Algebraically part, I just did it for a different type of function, but I'll do it for these also real quick. So one of them is x squared minus 4. My throat hurts. Yeah, square root of x plus 4. Luckily, I have no friends, so I have like no one to talk to, so I don't have to talk unless I'm like teaching. Okay. So if we compose them, f of f inverse of x, then what we're gonna get is you have to explain why you like have all these like bisexual friends and stuff, but you could explain some other day. No, I'm kidding. Giving you a hard time. I know you have a boyfriend. Okay. So the squaring and the square rooting get rid of each other. So you get x plus 4 minus 4. The plus 4 minus 4 get rid of each other. So equals x over. Make sense?
Yeah.
Okay. 8. Suppose f and g both have inverses and that are functions, and f of 1 and blah 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 blah. Find the following. Okay, so you have to answer both. We haven't looked at a question like 8, so you have to answer this question in full. Go ahead, talk to me.
Okay.
So what's f inverse of 3?
4.
Nice.
Oh, inverse. Sorry.
Yeah, it's okay.
Sorry, I'm just reading it.
It's okay.
Okay. So f inverse of 3. I don't think she's ever given us a problem like this.
It's okay. So what does f of 1 is equal to 7 mean as a coordinate?
Well, like as a coordinate, wouldn't that
1 comma 7 is on it. It's okay. It's okay.
Yeah.
And then what about the f of 2 equals 3? What does that mean?
2 comma 3?
Yeah, f of 2 equals 3 means 2 comma 3 is on it. F of whatever the next one is, 3 is 4. What does that mean?
Could you repeat that? Sorry,
Yeah, sure. It's okay. It's okay. 3, 4 is on it. All right. So this is good enough. Now, if I gave it to you as coordinates, how would you find the coordinates of the inverse?
Swap them.
Yeah, exactly. So that means 7, 1 is on the inverse. So 7, 1 is on the inverse. 3, 2 is on the inverse. And 4, 3 is on the inverse. So if we go backwards on the translation, this means f inverse of 7 is equal to 1. And therefore, next I'm going to write what? F inverse of what?
3.
Is?
2.
Exactly. So you could do this kind, basically swap the x and the y values so the input becomes the output becomes the input, and that's what you're looking for. Fair?
Yeah.
Okay, talk to me about B.
Okay, so if g of 7, would g of 7, would that equal 8? No.
Like, you're not doing the inverse, you're literally just doing g of 7. What's that? G inverse of 7 is 8, but go ahead.
So if you plug g of 7...
You have that info. What does it say it is?
Oh, 4.
Yeah, it's okay. It's okay. It's okay. It's okay. It's late. So now what we have is f inverse of 4. Make sense?
Yeah, so then it would be 3.
Yes. Bingo. Good job. Excellent. Okay. Find the vertex and the intercept, blah, blah, blah. Determine the domain and range. I feel like 9 we've done. 10, the Archer stuff, like the word problem. I feel like, if you, I'll go with what you say, but we did it on, we did it last time. So, and what we said is like, it's always about like, the maximum when you throw something, like we used a baseball example, and the maximum is going to occur at x equals minus b over 2a. And you take that and you plug it into the function to find the y value. If it said what is the maximum y value, that's really what they're going to ask you in these kinds of questions. And find the horizontal distance the arrow travels. What you have to do for that is set it equal to 0. So if you set f of x equal to 0, what I said last time, which I'll repeat quickly, is it tells you this value and this value. And this value in real life, I said, doesn't make sense because it's going to be a negative number and we don't have negative time and negative distance, blah, blah, blah. So you're just going to say what this one is. So for the maximum horizontal distance, you just have to set it equal to 0. And I think I just summarized that whole question unless you need to.
Yeah, no, I think I'm good.
Okay, all right. 11, finally. And I am going to guess that it's going to have to do with a parabola, blah, blah, blah. But anyway, let's do 11, and I will say 12 very quickly. But sorry, go ahead for 11. What are you gonna say?
Yeah, just give me a second.
It's okay, no worries.
Okay, so it wants the length and the width of the plot. Okay, and it's a rectangle. So I guess here you could start with, wouldn't you want to just find the, like the distance, the other like space that it connects to the river with, that would also have to be 600 minus 2x, right?
Yeah, exactly. So, but I'll do this one real quick. It's because we've already done a question similar to it. It's just like a longer word problem. So all it is this. It's just like the P question. Only there it was product. This time it's area. And like in the P question, we had another equation that allowed us to get rid of y. But here they didn't use x and y. They used stuff that has an x's in it in both cases. So all you have to do is just do x times, and then it's 600 minus 2x. Surprise, surprise, it's going to be a parabola facing down since they're asking you for a maximum. So you have 600x minus 2x squared. If we lead with the x squared, you have minus 2x squared plus 600x. And then now, since it's maximum, all you have to do is minus b over 2a. So that would be minus 600 all over 2 times negative 2. And so simplify that. What's that going to say? Like 600 over 4, 600, so that's 150. But minus b over 2a is telling you where the maximum area is going to occur. So to find the maximum area, you need to plug in 150 into this a function. So the maximum area is going to be a equals 150 times 600 minus 2 times 150, which is 150 times 600 minus 2 times 150 is 600 minus 300, which is 300. So it's 150 times 300, which is 45000. I did it very fast, but are we good?
Yeah.
Okay, cool. For 12, f plus g, I know you know how to do. F minus g, I know you know how to do. With the question we said, which I'm pretty sure I don't need to repeat, is when you do minus f, g minus f, put a parenthesis in front of f so as to distribute the negative sign. F times g, that's just a matter of foiling. We don't need to do that. And so very quickly, on to f over g. F over g is going to say f of just same as writing f of x over g of x. So that's going to say x squared minus 3 over x. Sorry, no, it's f over g. F is on top, so x squared plus 1. X squared plus 1 over x squared minus 3. And they're asking you, I know you know how to do this part, they're asking you for the domain. So the domain for all of them, except for d, is all real numbers. When you multiply two quadratics or polynomials, you're just going to get another polynomial quadratic. The domain is all real numbers for that. When you add them, same thing. When you subtract them, same thing. The only caution is when you're dividing them. When you're dividing them, as always, we're not allowed a 0 in the denominator. So that means x squared minus 3 is not equal to 0. So that means x squared is not equal to 3. Taking the square root, it means x is not equal to plus or minus the square root of 3 over. So all real numbers except for positive and negative square root of 3. Now, if the question had been g of x over f of x, just to, like, again, go the extra because we were trying to get an a, what that would have said is this time it would have been this, x squared plus 1 would have been in the bottom. But wait, you could graph the quadratic x squared plus 1. It's like above the x-axis. It's never 0. And what I said in the past is x squared plus a number is never equal to 0. So if it was this situation, g of x over f of x, where it's x squared plus a number in the denominator, the answer for the domain would be all real numbers, because, well, the denominator would never be 0. Does that make sense?
Yeah.
Okay. All right, love. You're amazing, and I love you, and I'm so sorry that we had to, like, talk, but it's a big test, so we needed to do this. Like, work carefully. Like, if you need to draw a number line on some of those places, do a number line, but make sure we get an A. Work cautiously and carefully. If you do that, I'm sure you'll get an A. Fair?
Yeah.
Okay, love. Have a good night, okay?
You too.
All right, bye.
Bye.
Get some rest.